squared minus 5x plus 6 equals 0. It's easy enough to imagine that the factors are x minus 2 and x minus 3. So the roots 2 and 3. However, an equation like this, did you solve this mentally?
Hindi, po. By quadratic.
You did. Wait, how did you solve this? 8u to the 4 minus 8u squared plus 15 over 32. You used the quadratic formula. Did you do everything in your head, in your mind, or did you write things down?
Yes or no?
Yes, using ano po, nilagay, and I just added it with the calculator.
Oh, you just typed it into a calculator. All right, okay. So I'm gonna trust this, but for solutions like this, because ultimately, what's stopping us from just solving an equation just by doing it mechanically by plugging it into a machine? So it would still be much more desirable to, if possible, do it by hand. All right, so here it would involve, using the usual substitution for u squared. So I understand we're going to end up with 4 roots. Okay, and these are the different values of 4x. Now what you did down here is eliminate. Actually, hold on, sorry. This is x. X is between 135 over 2 degrees and 90 degrees, which means x is in the first quadrant. And because x is in the first quadrant, that means the cosine of x is positive, which allows us to eliminate right away.
Eliminate yung mga negative.
So not necessary. Also this. So because cosine of x is positive, then that leaves us with only square root of 15 over 4 and also 1 over 4. And I see that you used your calculator to try to figure out which is the correct answer for the correct value of cosine x. Is it square root of 15 over 4 or 1 over 4? You eliminated square root of 15 over 4 because its cosine inverse would be, and then, well, the cosine inverse of square root of 15 over 4 would be these angles, and none of them are inside 135 over 2 degrees and 90 degrees. So that's what you did to eliminate this. So this is eliminated. So that leaves us with just 1/4. Cosine of x is equal to 1/4. And then as soon as you have that, trying to figure out the values of cosine 2x and cosine 3x isn't so bad. So cosine 2x is, okay, let me make things larger, make it easier to see.
Pwede rin po ba ng pwede rin pala pong walang calculator din. Di ba po 4x?
Yes.
Half angle
That's,
formula o kaya double angle formula.
Yes. That is, yeah, that's what I would have gone for. But let me show you as well what I would have done. Now, this part of the solution involves trying to identify the value of sine of 2x. You're right about this formula. However, I'm reminded of the following, because at this point we already have the cosine of 4x, 2x, and x, and then we need to figure out 3x. Your solution necessitates trying to figure out the sine of x and also the sine of 2x. Figuring those things out is not overly complicated, but let me show you this alternative. You remember cosine of alpha plus beta equals cosine alpha. This is my shortcut, my shorthand. Make this. So if I was in a contest where speed's important, I write this down as CA/CB minus SA/SB. Cosine A cosine B minus sine A sine B.
Hindi po delta in Omicron.
Sabi ko nga, pag nasa contest, nagmamadali na kunwari eh. So, syempre, gagamitin ko symbols to easiest to write down. CACB plus SASB. If I add these two, so that's going to give me cosine A plus B plus cosine A minus B equals
this
twice
is not real.
Cosine A cosine B. So this is an identity that this is true no matter what A and B are. Now, at this point, we have the values of cosine 4x, cosine 2x, cosine x, and then we want to figure out what the value of cosine 3x is. So in this equation, there are 4 cosines. And so what we want to do is choose A and B such that these 4 cosines are going to end up being the cosines of 4x, 2x, x, and 3x. So one way to do that is by letting A be 3x, let B be x. So we get the cosine of 4x. So that's cosine of A plus B. Cosine of A minus B is cosine of 2x. Here on the right side, twice cosine of 3x times the cosine of x. And the cosine of 4x, let's plug things in. Cosine of 2x, you ended up with negative 7 over 8. The cosine of 4x was given originally as 17 over 32. Oh, we're looking for the cosine of 3x. The cosine of x is 1/4. So let's clean things up. Let's multiply everything by 32. So the left side is going to be 17 minus 28. Here on the right side, 32 over 4 is 8 times 2, 16. 16 cosine of 3x. 17 minus 28 is negative 11, which means cosine of 3x is negative 11 over 16, which is what you ended up with. So this is not very good.
16.
Yeah, negative 11 over 16. Now, when I first looked at your solution, I think I would have done it this way.
Yung half angle formula, this is find cosine 2x from here.
Yeah, we could already figure out cosine of 2x from here. This is 2 and then cosine squared 2x minus 1, which makes cosine squared 2x equals 17 over 32 plus 1, then multiplied by 1/2. So that's going to give us 1/2 of 17 plus 32 is 49. So we have 49 over 64, which makes cosine of 2x equal to plus or minus 7 over 8. And then that's consistent with your cosine of 2x here, which is negative 7 over 8. So what we got to do is, well, decide which of these two values is the correct answer. Is it plus or minus 17 over 8? And that's where the fact that 4x is between 270 degrees and 360 degrees, where that's going to come in. So 2x is less than 180 degrees, and it's greater than 135 degrees, which means that 2x is in the second quadrant, which means that the cosine of 2x must be negative, which means that the cosine of 2x cannot be positive 7 over 8, but rather -7 over 8. So at this juncture, what remains to be done is to figure out cosine of x and cosine 3x. So, well, again, this is going to be 2 cosine squared x minus 1, and then that's equal to -7 over 8. So there's a quadratic equation that has to be solved, but you know what? Well, overall, it's not really a typical quadratic equation where you have to use a quadratic formula because this is 2 cosine squared x is 1/2 of 1 minus 7 over 8, half of 1/8, so that's 1 over 16. So cosine x is plus or minus 1/4. And then I think we already argued that cosine of x is going to be in the first quadrant. That's because here cosine x is less than 90 degrees, greater than 135 degrees over 2. So that means that x is in the first quadrant, which means that cosine of x is positive, which implies that cosine of x cannot be -1/4. Therefore, it must be +1/4. So still the same answers, but by being conscious about all these other things, you get to, for instance, remove the awkward cosine inverse computation. All right, because that's a computation that depends on the calculator. Sure, go ahead, use it. All right, but the advantage of being able to do things. Okay, some things you really need a calculator for them. Some things apparently you could do without using a calculator. I think it's a powerful thing to be able to do that. To be able to do things without using a calculator, if it was possible, right? It sort of, it kind of frees you up.
Me,
You're
after
free to
not
do the
using a
computations.
calculator po, I use the
Yeah.
computer.
Okay, or any calculating device. Yun yung naisip ko nakita ko, ay gumamit ng cosine inverse of square root of 15 over 4. So as you can see, hey, we did not have any need for a calculator at all for this entire problem.
Opo.
Okay, and so the discussion last time was mainly about some of the special segments related to a triangle. So we were beforehand discussing circles, different properties of circles. We kind of left that because we last time went back to triangles because there were things about triangles that I forgot to do. So we will continue back to triangles and circles. Now, the problems we've been looking at have been a lot of it were medyo regular standards. So
Oh no!
I looked
That means something.
for
The Olympiad problem, ano po, the Olympiad problems have been unleashed.
right here.
Hindi po nakagawa si Josh ng problems kasi parang I just felt na sabi ko yung mga nagawa na namin before ma-review niya para ma-connect niya po yung sa
Right, right,
present.
right, right. It's okay to go back there.
Kasi
Example.
kunyari po yung mga in-center, parang maganda mga circumcenter, parang 2018 pa yata po na nadaanan ni Joshua. Kaya sabi ko
Okay,
baka
okay.
hindi niya
Balikan muna.
matandaan na.
That's cool. That's fine. So maganda din ng ganito ano self well one student. So we go at your pace depende sa parang we can best decide, you can best decide in terms of what would be most helpful.
Apo.
So PQR are the midpoints of the medians of triangle ABC. If the area of ABC is equal to 1024, find the area of PQR. All right. So
What is geometry po without figures? So,
well, we draw. Okay, so A, B, C, and then medians. So that's from each vertex going to the midpoint. So this is the midpoint of AC, and then here is the midpoint of AB, and we know that the medians are concurrent. They intersect at a point called the median. Let's label the endpoints of the medians, the 7 vertices as D, E, and F. And then PQR are the midpoints. Now the problem doesn't say which midpoint belongs to which median, but that doesn't matter because there are three medians, there are three midpoints, they form the triangle. So however you name the midpoints, so let's label them arbitrarily. So let P, the first of PQR, to be the midpoint of AD. Now when we draw or when we analyze the geometry problem, it helps to already recognize some facts, such as when you locate the midpoint of AD, I'm drawing it here, P, and I drew it so that it's the same level as F and E. Is that justified? Is P on FE or not necessarily? What do you think?
seems untrue because in people it looks like it's intentionally off placed.
So is F are FP collinear? What do you think?
I don't think po. They
Negative?
could be, from the figure po, it doesn't even appear that that P is the midpoint of AD. So I have a little faith in that proposition po.
Yeah, but I think that's also because F doesn't seem to be midway between A and B, is it?
Di rin po. Kaya nga po.
But anyway, what do you think? So maybe my drawing is off, but based on the facts.
P po doesn't seem to be the midpoint po man ng AD eh. So I have little faith that FP and E are even collinear.
Hindi, what if they are, it's up to scale yung drawing?
Oh,
I don't even
well,
consider.
ganito. What do we know about F and E?
F and E are the midpoints. Wait, actually, F and E will be parallel to BC. Okay, yes.
Mm-hmm.
It is the part of the middle triangle. Okay, so
Yes.
P P P P P P P. Okay.
So you see what happened there? If you take the midpoints of two sides of a triangle, the segment connecting them is parallel to the third
Yes,
side.
I think it's the median of the triangle.
All right. But now, instead of looking at A, B, C, let's say you focus on
Yung
A,
mid segment,
B, C.
mid segment po or midline ba? Parang midline yata po something yung
Midline,
tawag.
midline.
Yes,
Okay.
midline.
So FE is the midline of ABC. What about triangle ABD?
It's F something. Ah yes, it is F. It is FP.
Hmm. And so FP is parallel to BD.
No, it's not real. I must be living in
Yes,
a dream.
yes, it is. All right. So you see, P is on the same level as FE. If BC is horizontal, FPE is also horizontal. Okay.
This is merely a dream. I cannot possibly be living in it.
All right. So therefore, it's the same thing as well with, let's say, when you connect E and D,
Alam po na niwan.
uh,
So
and F and D.
theory. If FP and E are collinear, and then if we prove that FP is congruent to PE, then we can similarly prove FQ is congruent to QD and ER is congruent to DR. Then
Mhm.
thus we can prove that PQR is the middle triangle of FDE, DEF, which is in turn the middle triangle of ABC.
So,
So, so I don't know. I will we will try to prove it somehow.
sorry,
Mm,
what's your claim? What's your claim?
if we can prove that FP is congruent to PE, and then then we can prove that FQ is congruent to QD, and DR is congruent to RE. So then we can prove that PQR is the medial triangle of DEF, which in turn the medial triangle of ABC.
Mhm.
So PQR will be 1/16th of the area of one ABC.
Yes.
But how can we prove that FP is congruent to PE?
Nah, that's what you think
Yes,
of.
it's
Yan,
possible.
pag-isipan mo.
If BD is congruent to DC because it's the midpoint. And then
Mhm.
I forgot how to buy it as well. Okay, by SAS uh AB is kung is AB is similar to AF. Yes, so triangle ABD is similar to AFP. Is Armed Forces of the Philippines, and the
Mhm.
triangle ADC is similar to triangle APE. So then by transitivity of BD is congruent to DC, then FP must also be congruent to PE because they are similar.
Yes. There
Oh
you
wait,
go.
that's
So
not
yes.
actually. Do we actually know they are similar by the same amount? Yes, too, because AF over AB is equal to one half, and AE over
Mhm.
AC is also equal to one half.
Yeah.
Okay,
So it's the
then
same ratio.
by similar with the other medians, and then thus a PQR like earlier po the logic is PQR is 1/16th of ABC, 1/16th 1024 divided by 16.
All right. Okay. So, how do you summarize your argument again? Why are FP and EP equal?
Okay, so the okay. Wait. AF over AB is one half. Same for AP over AD. So by
AF over
SAS,
AB one half. What else?
AP over AD and AE over AC,
Okay. All right.
and
So
AE over AC.
therefore,
Yes.
so
Since BAD is reflexive to itself, then S by SAS, triangle BAD triangle bad is similar to triangle AFP or FAP more of
all right, 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 right.
So
So BAD and then FAP, so there's similar
yes, and they are
triangles.
similar by a scale of one half. Yes.
One half. Yes, that's the
So
ratio of
that's AF
similitude.
over
One half.
AB. Yes, and then similarly, APE must be ADC must be similar to APE
Mm-hmm.
by yeah, AP is similar to ADC by one half, scale of one half too, because AE over AC is equal to one half. Then since BD is equal to DC, D is the midpoint. Then what? Then because they are because PFP and PE by the definition of similarity are similar by the same scale. Then since BD is congruent to DC, FP must be equal to PE.
Okay. All right.
Similarly for all of the others, we can also derive that FQ is congruent to QD and etc. And then from there, if Q is the midpoint of FD, P is the midpoint of FE, and R is the midpoint of DE, then it must be the medial triangle of
Mhm.
DEF, which was already known to be the medial triangle of ABC. And thus,
All
that
right.
is 1/4 times 1/4 of ABC. Or
Okay. So
1/16 of
there you go.
ABC, which is 64.
Okay. So there you go. So that's it in terms of, so we're able to recognize medial triangles here. Okay. So yeah, that's a productive point of view here. Okay, so medial triangles. The medial triangle is one half, one fourth the area of the triangle it's based on. So we are looking into the medial triangle twice in succession. So we get 1/16. Okay. So PQR is the medial triangle of DEF. So PQR has area one fourth of the area of DEF. And then DEF is the medial triangle of, wait, actually, when I refer to something as being the medial triangle of something, I'm not referring to the areas, but rather the triangle itself. So triangle PQR is the medial triangle of triangle DEF. Then triangle DEF is the medial triangle of triangle ABC. So um, PQR, wait, rather DEF ABC. So that makes PQR 1/16, the area of ABC. So that's just going to be 1024/16. 2 to the 10 over 2 to the 4. So that's going to be 2 to the 6. So that's 64. All right.
No po.
Mm. All right, so we didn't write down anymore the entire argument, but eventually it's going to lead to P is the midpoint of FE. And then it's the same story. Q and R are the midpoints of the green segments that are drawn here. In triangle ABC, the medians AM and CN, two sides VC and AB respectively intersect in point O. P is the midpoint of side AC, and MP intersects CN in Q. Find the ratio of the area of triangle ABC to the area of triangle OMQ. So let's see what these points are. So triangle ABC, the medians are, we have two medians, AM and CN. So if AM is the median, that means M is the midpoint of BC. The other median is CN, which means N is the midpoint of AB. The medians AM and CN intersect in point O, so that makes O the centroid.
Centroid.
P is the midpoint of side AC. So that means NP is going to be horizontal, parallel to BC. All right, so M and P, that's the middle triangle. MP intersects CN in Q. So that would make this Q. OMQ versus ABC. So what ratio does OMQ fill up over ABC? Well, actually, it's the reciprocal, ABC over OMQ. But of course, if one wishes to figure out OMQ first over ABC, that's fine as well. To just take the reciprocal. All right. I guess what we got to do is figure out how the area of OMQ is related to something else here. Where's OMQ? This is OMQ. O is not just any other point, but it's the centroid. And then this is OMQ.
Ah, yes, I see. It is actually 1/6 of the medial triangle, or 1/24 of the big. Easy.
Wait, what's that observation about OMQ?
Spoiled the movie po. So it is it's 1/6 of the medial triangle.
OMQ has area 1/6 of the medial triangle.
Okay, so
yeah, how?
how can I prove that po? Because earlier po we already proved that MQP is the and MQ and P are collinear.
Yeah.
So,
Okay. Oh, you're right. Okay, I see your points. So, yeah, but go ahead. Go ahead.
And Q is the midpoint of MP.
Mm-hmm.
So if Q is the midpoint of MP, at saka ano po, I forgot to mention, in the middle triangle, the centroid, which is also the centroid of the, middle triangle. So wait lang. Since Oppo is also the centroid of the middle triangle, there's a theorem po kasi, I forgot what the name of the theorem is.
Okay.
Then it is divided into 6 congruent sections.
Yeah. Wait, not 6 congruent sections, but 6 sections with equal areas.
Ay, about six sections with equal areas.
All
Those
right.
six
Yeah,
sections
I see. I see. Okay. Good. Good.
are produced by the medians po themselves.
Okay. So OMQ is 1/6 M and P, right? That's what you're saying.
Opo.
Yes. But then relative to ABC, M and P is what?
Relative to ABC, M, and P is 1/4 of it. It's the middle triangle.
Right. ABC. So this makes it 1/24 of ABC. Nice. All right. Okay. So again, it's a realization that the green shaded thing is one of the 6 sections that are produced if we draw the medians of M and P. Okay. So into the fact that the centroid of ABC is O, then the centroid of MPN is actually also O. And then Q is the midpoint of MP, so OMQ is also going to be 1/6 the area of the yellow triangle. So great. So actually that's it. We have our answer easy enough. ABC over OMQ equals 24 right away. Good, good, good. Okay, tapos as far as okay. Other problems. These are miscellaneous problems. Okay, example. So here's the illustration, not drawn to scale. P0.
Bakit hindi po drawn to scale? Dapat meron po yung mga, yung Microsoft po big should message Bill Gates, he has to integrate GeoGebra into OneNote.
Andito na, alright. Then this is P2, and then P3, and then P4, okay, and then so on. But here are the givens. In the semi-circle shown, P0, P1 equals 2. So I guess all that's saying is that the radius is equal to 1 because P0, P1 is a diameter. Okay, so we have that, and then angle P0, P1, P2 is 1 degree. Angle P1, P2, P3 is 2 degrees.
3 degrees.
Angle P2, P3, P4 is 3 degrees. So where are those angular measurements? This is 1 degree. This is 2 degrees, 3 degrees, and onwards, so on. Okay. And so on. Okay. So the general idea is that angle P sub k minus 1, P sub k, P sub k plus 1 is equal to k degrees. If P sub k plus 1 is the first coordinate. Because if you connect any two p's P sub k and P sub k plus 1, where we see that those with even indices are there on the left, and those with odd indices are there on the right. So P sub k plus 1, of course, it's not going to be horizontal, but one endpoint is somewhere on the left, and the other endpoint is somewhere on the right. Now, P sub k plus 1 is the first chord whose length is less than 1. Find k.
I'm rather satisfied by this problem.
Okay. So so P sub k plus 1. Now let's write down some measurements of some arcs. Okay, let's try to get a pattern out of the things that we have here. So what's the measure of P0, P2? Well, because the fact that you have that 1 degree angle, that has an implication on the length of this arc, right?
Abo.
What's the measure of that arc?
1. 2. So degree.
How many degrees is that arc?
2 degrees po.
2 degrees.
Oh.
How about this?
I have no idea. 4 degrees.
4 degrees.
Yes.
All right. Because we're trying to identify the first k so that this first chord has length less than 1. Let's say it's somewhere here. Okay. Let's say P sub k is here, and then P sub k plus 1 is here. Actually, not exactly 1, but less than 1. But okay, suppose it's 1. What's the implication on the length of this arc? What do you think? Keep in mind.
It could be we could use regions.
P sub k plus 1. Let's say the length of this arc is 1.
Arc po or no, or chord?
Sorry, this chord. 1.
Okay.
The center is here.
No, it's not possible. I realized.
What's the radius? And because it's an equilateral triangle, what's this angle here?
Oh, this is so sad. 60
That's
degrees.
sad. It's happy. What's this angle here?
60 degrees.
Which makes this arc, what's the measure of this arc?
60 degrees.
60 degrees. If the chord PK plus 1 has length 1, but if P sub k plus 1 is less than 1, what's the implication on the arc?
61 degrees.
Kunwari no PK plus 1 slightly smaller than 1. What do you think is going to happen to the angle opposite the arc? is it going to be still 60 degrees, larger than or smaller than 60 degrees?
Okay. Smaller than.
All right.
Okay, 59
So
degrees.
so we can now convert the task into the following. Find K, find the first K so that the arc length, or sorry, not really the arc length, but the measure of the arc dips lower than 60 degrees. Okay? So, tignan natin, ng mga consecutive. So, P0, P1, that's 180 degrees. Because P0 to P1, whether it's the arc above the diameter or below the diameter that's drawn, that's a semicircle. So, okay, 180 degrees. What about P1, P2? What's the degree measure of P1, P2?
4 degrees. I mean.
P1, P2. So,
178 degrees.
all right, 178 degrees. So I know you subtracted, but rather than subtract, we want to keep track of the change. So again, this is 178 degrees, but how did you get that? 180 degrees minus 2. What about P2, P3? So why am I looking at P2, P3? Because this is an arc whose endpoints are points P, which have consecutive indices. And why are we interested in that? Because we're investigating chords with consecutive indices.
1, 2.
Actually, ito, arcs whose endpoints have consecutive indices. So P2, P3. This is lower than 180 degrees, but minus
-6.
minus 6. Where did 6 come from?
2 plus 4.
2 plus 4, because that's, all right, so minus 6 degrees, 2 plus 4, but maybe this should be much faster now. What's the measure of arc P3, P4?
180 degrees minus 2 plus 4 plus 6.
So what's that?
12.
12. All right. So where are 2, 6, and 12 coming from? They're 2, they're 1, they're double 1 plus 2 plus 3. So this is 180 degrees minus twice 1. So let's say all measures are in degrees, so that I don't have to keep writing down the degree measure, the degree symbol. This is 180 minus 2, 1 plus 2. And this is 180 minus 2, 1 plus 2 plus 3, because that's where you get 2 plus 4 plus 6. It's double 1 plus 2 plus 3. Okay. So in general, p sub k plus 1, this arc will be of degree measure 180 minus twice 1 plus 2 plus 3 until, what's the last term? Is it k minus 1? Is it k, or is it k plus 1? What do you think is the last term?
K plus K minus 1.
Is it k minus 1?
Okay, so if K if yes, K, it is K actually.
It's k. All right. See how here it's 3 here coincides with the lower index 3. This 2 here coincides with the lower index 2. So we have 180 minus twice k plus 1 over 2, and all we want is the first k, so that would mean the lowest k so that this goes lower than 16. So now that we've converted into this algebraic inequality, it becomes a little bit more straightforward. 120 is greater than k times k plus 1. Yeah, because these two cancel. 180 minus 60 is 120. Now we are looking for the value of the integer k. K and k plus 1 are not the same, but they're close to each other. So rather than solving a quadratic inequality mechanically, it would be enough to look at perfect squares. So I'm thinking 11 squared is 121, so that's close enough. So if you look at 11 times 12, that's 132. What about the previous one? 10 times 11 is 110. So, and of course, 9 times 10 is 90, 10 times 11, 110, which is still lower than 120. But the first time we go higher than 120 is when k is 11. So the least k is 11. So that would be the answer. So P11, P12, that arc is the first arc, which is less than 60 degrees, which means P11, P12 is the first chord, which is shorter than 1 unit in length.
Yay!
Yay! Okay, so let's continue with basic facts about circles. So last time we already talked about the inscribed angle theorem, which you already know about. Okay. Opening up a reference here just to make sure that this is organized. Okay, hindi ako masyadong patalon-talon. Prove that a trapezoid is cyclic if and only if it is isosceles. Have I introduced the term, or are you familiar with the term cyclic when
Yes,
applied
it
to a
can be
quadrilateral?
described
So cyclic quadrilateral.
with all of its with all of its vertices that are it can be perfectly inscribed in a circle with all of its vertices touching.
All right, and then we talked about how opposite angles are going to be supplementary to each other. Yes.
Apo.
All right. Okay. Cool. So, wait. Oops, wrong page. So ito. Can you? And then when we say trapezoid is isosceles, can you imagine what that means? Are you familiar with that term?
Yes, it is. It's the non-parallel sides of the trapezoid are equal.
Yes. So
What is the
yeah,
origin of the term po isosceles?
I don't know. Iso means same, and then the last part, I don't know. Maybe it means sides.
Scaly? Kasi
I
basically po, diba? Yes.
okay. So I don't know. But iso is a prefix that occurs a lot in many mathematical terms, and it denotes a sense of things being the same in some respect. Iso.
Isotope po.
Okay. Isotope. You know what? You're right, but I don't know what a tope is. That the prefix iso describes. So I don't know in what regard it applies to isotopes. Ito,
Ah,
think
kaya,
about this. Okay,
skelos,
go ahead.
skeleton, kaya may skeleton po. Leg. Skelos.
Ah,
Isos.
okay.
Isos
Same.
equal. Skelos, leg.
Equal. Pwede, leg. O nga, no? That makes sense. Okay. So in an isosceles triangle, you have the two non-parallel sides are equal. Ano pa ang masasabi natin sa isang isosceles trapezoid? What else makes a trapezoid isosceles? Halimbawa,
Uh,
if you have a
base
trapezoid
angles
that's
are congruent.
sorry, what's that?
If base angles are congruent.
Yeah, the base angles are congruent. And equivalently, kasi if this is x degrees and this is x degrees, then nung nandito sa taas, this is going to be 180 degrees minus x degrees. This is going to be 180 degrees minus x degrees. So either the two lower angles, referred to as the base angles, are congruent. Equivalently, the two higher angles are congruent. Pareho ng measure. So any of those conditions mean that the trapezoid is isosceles. Now, can you see why this is so? A trapezoid is cyclic if and only if it is isosceles. How would you argue? Let's say a trapezoid is cyclic.
If it's, maybe we could use a proof of contradiction.
Okay.
Or
Suppose
suppose the trapezoid is actually not isosceles.
maybe baka naman kaya ng direct. So
But
suppose
are you sure po that's a circle?
no, but let's pretend it's a circle.
Just pretend na lang po.
Yeah, just pretend. Suppose A, B, C, D. And here in this figure, AB and CD are the parallel sides. So that's assumption. Let's justify it. Let us prove why this must be isosceles. Why must this be an isosceles trapezoid? Bakit kaya? Let angle ADC be delta. We can show that this is isosceles by showing that angle C must also be delta. Paano natin mapapakita na delta? Si angle C. Now, keep in mind, this is not just any arbitrary quadrilateral. This is a trapezoid. So we have to look into what makes this a trapezoid. Bakit ito trapezoid? What makes this a trapezoid?
Parallelity. The the arbitrary top and bottom are parallel to each other.
Parallel. So AB and CD are parallel. So can you draw a conclusion out of the parallelism of AB and CD? So given that angle ADC is delta, what can we conclude?
BCD is also delta.
Why is BCD also delta?
Because it is isosceles and the base angles must be equal.
And we're trying to prove that this is isosceles. We don't know that yet. That's our goal. Show that angle C is also delta.
Circular argument po yung ginagamit.
Yeah, circular argument. You claiming precisely what you need to prove.
Me after ano po, me after inciting Plato. I am suddenly
yeah. Okay. So we have to use the fact that this is a trapezoid.
Angle DAB is 180 minus delta. Found it.
Ayun, angle.
Angle AB is angle DAB is angle DAB is equal to 180 minus delta.
Okay, so since
Sound bulb.
DC CD is parallel, since CD and AB are parallel, then DAB all right, so now we've used the fact that the trapezoid is that the quadrilateral is a trapezoid because AB and CD are parallel, but we haven't used yet the fact that this is cyclic. In a cyclic quadrilateral, many things can be said about such a quadrilateral, but one of the things that are true about a cyclic quadrilateral, which hopefully will allow us to say something about angle C, is what?
CE is something. Okay,
so C is one of the angles of a cyclic quadrilateral. So think of the theorems, the properties involving an angle of a cyclic quadrilateral.
Yes, so it must be delta. No!
That's it. Okay, so see, just follow through the definition. We have to use the fact that the quadrilateral is a trapezoid. So we have to use a parallelism, and then the fact that it's cyclic. Keeping in mind that our conclusion should be about angle C. So angle DAB is 180 degrees minus C, since ABCD is cyclic, then angle DAB and angle BCD are supplementary. So angle BCD 180 degrees minus angle DAB. So 180 minus, there you go. Mabilis na algebra, 180 degrees minus delta. So that makes this delta. So angle BCD is also delta, and therefore ABCD is isosceles. All right, and then on the other hand, other direction, we're starting from the fact, the assumption that the quadrilateral is isosceles, but that this is a trapezoid. I suppose it's an isosceles trapezoid. And then what do we want to do? We want to show that this is cyclic. Can you think of an argument? So we want to show that this is cyclic. So we have to think. Kailan ba naging cyclic ang isang quadrilateral?
When it is cyclic.
All right, so what conditions must be satisfied for us to be able to conclude that it's cyclic?
The opposite angles are supplementary and
Yeah. All
I
right.
don't know.
Yes. Yes. Yes.
You know,
So either we look at A and C or B and D. So we have to show that A and C sum up to 180 degrees, or equivalently by symmetry, doesn't matter. You could pair up AC or B and D. But we start with the fact that this is an isosceles trapezoid. So first off, it's a trapezoid. So two sides are parallel. So let it be AB and CD.
opo.
Okay. So let this be delta. Because this is a trapezoid where you have two parallel sides, what can we conclude?
I don't know. So the adjacent angles are supplementary.
Which adjacent angles? Which angle adjacent to D? Is it angle A or angle C? Because to
I mean
from
the ano po, the adjacent in the adjacent one relative to the parallelism.
right,
And
right, right. So you're talking about DAB.
about the
Okay. So this uses the fact that the trapezoid is a trapezoid. The quadrilateral is a trapezoid. But now this is isosceles. This is isosceles trapezoid. So conclusion, dahil isosceles siya, are what's one of the many things that we can conclude here?
AD is congruent to BC, etc. D is
Yeah, AD congruent to BC, but we're doing an argument in terms of angles. So let's argue in terms of angles. Any other angle that we can name based on what we've drawn so far, precisely
angle B
because this is
congruent to angle C.
all right. So ibig sabihin, because angle D is delta, this ABCD is an isosceles trapezoid. How can we use that? What conclusion can we draw using the fact that this is an isosceles trapezoid? Angle D is delta. Therefore, is there any other angle that we can conclude the value of?
Angle B is 180 minus delta.
Why?
They are adjacent, not relative to the parallelism.
So from where did angle B inherit its measure of 180 degrees minus delta?
From either A or C.
Either A or C.
Or D. Actually, D rin. Kasi, this
Okay, pero just because D is delta, why is B delta?
B po is 180 minus delta.
Yeah. So if D is delta, why is B 180 minus delta?
This
If we're gonna
so the opposite
no,
angle.
but that's exactly what we're proving. We want to show that ABCD is cyclic.
Let's just use either C po, which is delta.
Pwede rin D.
Or A.
Or A. So either A or C, because ABC is isosceles, then angle BCD is equal to angle ADC, which is delta. All right. And then how do we wrap this up? So consequently, how do we wrap this up and conclude that the trapezoid is cyclic?
Delta is supplementary to B, and then C is supplementary to A.
All right. So there you go. So consequently, A and C are supplementary. So DAB plus angle BCD, 180 degrees. Therefore, ABCD is cyclic. Okay. Try to think about this. If a parallelogram is cyclic, then it must be what kind of parallelogram? If a parallelogram is cyclic, what can I conclude about that? About the fact that the parallelogram is cyclic?
It must be a trapezium. It must be a square.
It must be a square. We sure about that? So I'd like you to think about it.
The rectangle is easy to disprove.
All right. If a parallelogram is cyclic, then it must be a rectangle.
A rectangle.
All right. How would you argue that? Can you?
Because the only possible combination for equal angles on both equal adjacent angles, both of them both of them are wait lang. Uh, the only combination of supplementary angles from from a viewpoint of one angle, then every single other angle must be supplementary to it, because two of them, its direct adjacent ones they must be supplementary because of the definition of a parallelogram.
Yes.
And then the other one must also be supplementary to it because of it's cyclic. So the only possible combination is for alpha 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 to how will I argue this? 360 minus three of the same ones, three of the same angles. Or maybe there's a way to argue that three of the same angles must be 90 degrees. I don't know.
Okay, so why don't you think about it and then present your argument? All right.
Bang, 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 bang. Oh no.
Okay. So, next example.
Mysterious type of question po. The question has no
It doesn't have EX. But you're not gonna solve
it looks
anything.
familiar po.
I just want an argument.
It looks
I just
like it's
need an
been
argument.
it's been sugar coated.
And but as you see, there's nothing that needs to be solved for here. I just need an argument, a carefully thought out argument. It's actually not going to be a long argument, but this is practice in extracting what am I proving, what can I assume, because you would have to know where am I coming from, what's the given, and then what is that thing that I want to conclude, what's the conclusion.
Me after.
All right. Okay. This will do. No.
Gamitin tayo yung isa.
So in the figure,
Natin mo na. You will die. This is
H
the ortho center.
is orthocenter. It's the intersection of the altitudes. H is the orthocenter of triangle ABC.
I can feel it, boys. It's almost coming.
Extend
I think
AD.
mangyayari na po yung proving ng ano, yung ano po. Ay, yung 9 point.
The 9-point circle. Although wala pa tayo. Extend AD so it meets the circle
Kasi triangles,
triangle
triangles and circles.
ABC.
I see po you've used technologies ano po. Latest gift.
Okay, so extend the altitude AD so it meets the circumcircle of triangle ABC at P. So it's a point different from A.
Prove that the line from the orthocenter and the circumcenter intersect the center, right? Dies. I mean in center. Yes.
BHC and BPC are congruent.
This will be rather easy, but also rather hard. Okay. Anyway. Okay, we already have BC, which is congruent to itself, obviously. So already one done. We just have to prove BCH is a kite. Okay. Okay, so I don't know.
All right, so CF, AD, and BE aren't just any Chevians or Sevians, they are altitudes. So here's the hint, let theta be equal to angle BCF. Now, is there any other angle here which is also theta?
Yes.
So give me another angle which is equal to theta.
It is another angle. Okay, so uh-huh.
Find me another angle which is equal to theta. Using the many right triangles here. Those orange angles. What can we say about that?
Yes, I see. So the bow tie. FAH. Yes. So angle FAH of the bow tie
is also from the bow tie. So I see the bow tie. So okay, let's write that. BCF. Okay. Then so theta equals angle BCF, which is 90 degrees minus DHC, which is in orange. But then DHC is a vertical angle to angle FHA. But the 90 degrees minus FHA would be this angle up here. That's theta. That's going to be FAH. Okay, so angle FAH or angle BAP is theta. Wait, but so that I'm able to preserve the original drawing, let me put in my marking stand here.
I think po there's been there's been a slight misunderstanding.
What?
We would like to we would like to talk to you po with your car's extended warranty.
Okay. Anyway, so so that angle.
We want the CTRL-C and CTRL-VS truck again.
Sorry, I didn't get that. So ito,
Yeah, control C po, ano po yun? Oh no.
Sorry, what?
Control C.
I don't get it. Sorry.
Copy paste.
Oh, okay. Yeah, the copy paste. But I want to preserve the original drawing. So, okay. Now we have that angle theta there, close to angle A. Can you show me another angle that's also theta?
No. Okay. So.
So that angle up there is theta, and that angle BAP is an inscribed angle.
Angle BC, angle B B B B B, third letter in the alphabet, P.
All right, so that would make this also theta.
No ho ho.
So you see what happened?
It's AS already. We either need S or A. There's only one more angle left.
But did you see that it's gonna be the same thing? A similar argument. So, but let me write it down. So angle BAP and angle BCP. Angle BCP equals angle BAP, but then BAP is also theta. All right, so we were able to show that this angle and this angle are congruent. Similarly,
there is another. Actually, we can already prove po that PDC is already congruent to DHC.
So PDC is congruent to
DHC.
Wait, PDC is congruent to which triangle again?
HDC.
HDC, yes.
So, BD's H.
Similarly, if we call this angle beta, By following a similar
Why,
argument, can you
why
see?
beta and delta? Why beta and theta when you can
Kasi
do
yun,
delta and omicron?
delta na lang, delta na lang.
Yes! Goal achieved.
So, but by following the same argument, what angle is going to be equal to delta as well?
Bow tie. Yes. Okay, bow tie. Uh, HAE.
And then finally, if HAE is delta,
PBC.
all right, so this is also going to be
I
delta.
cannot believe it's possibly real.
Yes, it is real. Okay, so you just need to get used to being
We
able to
must be
relate
living,
different angles in a circle.
we must be living po in 1984 by George Orwell.
BCP, so CBP equals CBH.
Dystopian or real world we must live in.
So what were we asked to do? Prove that BHC and BPC are congruent. Do you see how that follows now?
By using the first letter of the alphabet as first letter of the alphabet theorem. Then
All
thus we
right.
can prove
Okay.
that they are
So
congruent.
so yeah, ASA. Therefore, triangle BHC is congruent to BPC since they share side BC, along with the angle congruences that we talked about. So BCH and BCP, and then angle CBH, CBP. Okay, so BPC, the one below, and BHC are congruent triangles. Next, follow up. Show that angle BHC equals 180 degrees minus angle BAC. Where is BAC? This is BAC. Okay, this is BAC. And then, so it's in a BAC.
No.
And then BHC is this angle.
Yes.
So actually, those two orange angles, they're supplementary to each other. We see BHC, the lower angle. Okay.
Cyclical, quadrilateral, and congruence.
So how exactly do you argue that?
The BPC is congruent to BHC. So that's by CPCTC.
Yeah.
BPC is congruent to BHC. And thus is supplementary to BAC because of the cyclic quadrilateral something something theorem.
All right, right. Opposite angles in the cyclic quadrilateral are supplementary. Okay. So the argument is because angle BHC equals angle BPC, and the reason is because of the congruent triangles. So this is since triangle BHC congruent to triangle BPC, and then with BPC, this is 180 degrees minus angle BAC. This is because BPCA is cyclic. Okay. Tapos, okay. Y are A, F, H, E, B, D, B, A, F, H, E, and then B, D, H, F, and then C, E, H, D, all cyclic. Why are each of these three quadrilaterals cyclic quadrilaterals?
Uh,
Let's have a look at A, F, H, E.
Are they even cyclic?
Yes, they are.
What? No way. Wait lang. How are they cyclic po? Okay. A, F, H, E. Yes.
So based on this illustration, what's the only thing that we're sure about A, F, H, E?
Okay. G.
Look at AFHE, the drawing that I made down there on the lower left of the page. I made sure to point out something in the figure. What's
Both
angle
of them
F?
are, the opposite angles are... is there any other quadrilateral po na ganun? Actually, yes. Kite. Pero, maybe if we can prove that AF is congruent to AE or FA is congruent to HE, then we can prove that it's a quadrilateral. It's a rectangle, I mean.
Does it have to be a rectangle to be cyclic?
No, actually. It just needs supplementary opposite angles.
Yes. And don't we have that?
So, do we indeed have that?
What's the measure of angle F?
Angle F. 90.
What about angle E?
92. 90. 90 also.
And, and so, what can we say about the opposite angles F and E?
They are congruent. Yes.
And are they supplementary?
Yes. Opo.
And that's it.
So there's no need to prove that FAE is supplementary to FHE.
Actually, it would follow.
Yes.
You see?
90.
So-
90.
Yes.
So-
Okay. We can prove that. Let's say we set one of them as alpha and the other is beta, and then it will be 180 minus beta, and then 180 minus alpha. Add them, it will be 360 minus alpha minus beta. So if we add those together, they will be. Wait.
Ganito. FAEH is a quadrilateral.
It's 90 minus alpha and the other one is 90 minus beta. If we add them, this 180 minus alpha minus beta. Adding that to alpha and beta, that will be just 180. Yes, it follows.
Why do we even need to do that? No, alpha and beta. What's alpha? Is that angle A and beta is angle H?
Any of the two angles po. Any two
Angles
adjacent
A and two adjacent angles. All right. But okay. Di ba at angles F and E you have 90 degrees?
Abo.
Precisely because F, D, and E are feet of the altitudes. So you have those 90-degree angles there, which means F and E are supplementary. In a quadrilateral, isn't the sum of all internal angles 360 degrees? Which means if you already have a pair of opposite angles adding up to 180 degrees, it forces the other two angles should also have a sum of 180 degrees.
I forgot
You cannot go
about
against that.
about quadrilaterals.
All right. So the argument is simply because angle F plus angle E, they're both 90 degrees. And therefore, you have a pair of opposite angles adding up to 180 degrees. Therefore, AFHE is cyclic. In fact, aside from the fact that it is cyclic, what can we say about AH relative to the circle? Given the fact that, if you're going to draw the circle through A, F, and H, okay, this is going to pass through AH isn't just any chord, but what special chord does AH turn out to be?
The diameter?
Yes, in fact, AH is a diameter. Is a diameter of AFHE. All right. That's because, remember, in a circle, if an inscribed angle is 90 degrees, then the chord corresponding to it must be a diameter. So that makes AH not just any chord, but it's in fact the longest chord. It's a diameter. Yay. Okay. Now on to the discussion theorem. The drawing ko na lang. I have a circle, and let me draw two secants. So instead of a tangent, which intersects the circle in just one point, so two secant lines with the following points of intersection: AB for one line, and then for the other line, C and D. And then consider these two angles. Now they're vertical angles, therefore they are congruent. Now let's have a look at the angles, so rather the arcs BD and AC, which are the arcs opposite these two angles. Question: because those two angles are congruent, does it mean AC and BD are congruent? Are they necessarily congruent, Joshua? Or no? They don't have to be congruent.
Because the chords don't intersect at the center.
Yes, precisely. The point of intersection is not necessarily the center. However, even though the two marked angles are not inscribed angles, wait, why are they not inscribed angles? Because for an inscribed angle, the vertex must be on the circle. However, the vertex of those two marked angles is somewhere in the interior of the circle. But hey, it turns out that we still have a way of relating that angle. Let's call their point of intersection point P. Angle APC, which is the same as BPD, we can still relate that to the two orange arcs. Have you encountered this theorem before? Angle APC can be written in terms of the two orange arcs, AC and BD. It's half the measure of arcs AC and BD added together.
I think
So,
hindi dating natin, hindi ko maalala na eh.
all right, okay. So prove lang natin quickly why this is true. Okay, proof would be as follows.
No!
Yes, just did it. So, ng angle na yon, we have to relate it to some other angles. Let me connect AD. Okay. AD, and then there are two angles here in APD. This angle and this angle. Okay. Now those angles in light blue, they are now inscribed angles corresponding to the orange arcs. So for instance, angle ADP, the first light blue angle, the one on the left, is the inscribed angle to arc AC. Well, rather, it's an inscribed angle to arc AC. So that makes angle ADP half arc AC. What about angle DAB? What can we say about angle DAB?
Angle dab?
Yeah, that.
Oh, actually, angle dab is
Which is
you can,
angle DAB as well.
why are they congruent? Why is angle CDA congruent to angle dab?
Which one?
Angle
CDA?
CD, why is it congruent to angle dab?
We're not saying they're congruent. I didn't put any markings there. So again, let me call this X and this is Y.
Okay po. Okay. Kala ko po CD. Okay, anyway.
So just look at angle DAP or angle DAB or angle
dab is,
BAD.
one half of arc dB. No, it's twice. Yes, it is one half of arc dB. Minor.
Okay. But now, the angle Z.
I see now. Okay, so angle X din po is the same, similarly. So
Can we really?
so
Okay, sorry, what's that?
one half dB plus one half CA is equal to one half X plus one half Y. But by the is that the remote anterior angle theorem? Yes. So X plus Y must equal to Z. So that's
Ayan.
Z is equal to one half BD plus CA.
All right, so angle Z is X plus Y. So that's precisely it. So angle APC, that's Z. This is equal to X plus Y, so that's angle ADP plus angle DAP. So you have half of arc AC plus half of arc BD written nicely. The average of AC and BD. So quick example. Not drawn to scale. MN RQP. If arc MN is 40 degrees and PQ is 60 degrees, then what's angle PRQ?
Uh, 50.
All right, angle PRQ is 50 degrees. And then B. If arc MQ is 130 degrees and angle PRN equals 135 degrees. Then what you say about arc NP? But you see that the pieces here in B are the three pieces that make up the theorem. Angle PRN. So PRN, so ito yun, is half MQ plus NP. Then angle PRN is 135 degrees. MQ is 130 degrees. And we're looking for arc NP's measure, so we should be able to figure it out. Twice 135 is 270 minus 130, that's 140 degrees. Yay!
Yay!
Okay. So what happened here is that in this theorem, the two secant lines intersected inside the circle. What if they intersect
No!
outside the circle? I think we can do better than the circle.
Bro, literally. Literally.
A, B, C, D, and then P. So our two secants intersect at a point P, and the following angle is formed. Let me use the same color coding. Okay, no need. And then, well, the rays of this angle trap the following two arcs of the circle. Arc BD and AC. This stands to reason that the measure of the angle that we're looking at is related to the measures of the arcs. But the situation is different from what we saw from the previous theorem, where in the previous theorem, the angle formed by the two secant lines is related to the measures of the two arcs that are intercepted. So here, those two intercepted arcs are AC and BD. Again, the situation is different. P is outside. The conclusion, angle APC is 1/2, not the sum, but the difference of the two arcs. Now, clearly, the farther arc AC is bigger than the closer arc BD. So this is 1/2 AC minus BD. And we want to prove this. Proof. Ano strategy natin kanina sa pag-prove? What we did was, because we know the conclusion involves the arcs AC and BD, what we did was we drew that segment AD, but why did we draw the blue chord AD? How did that help us? But because by drawing this chord AD, we were able to identify the angles X and Y, which are related to the two orange arcs. So if we want to do something similar, then we have to, in this figure, locate two angles which are related to the two orange arcs. So let's have a look at arc AC. So kailangan natin mag-drawing na...
Ano po yung nearsightedness sa farsightedness?
Yeah, oo, parang eyeball, no?
Yung mga ano po, yung map diagram, yung gumagano'n. Parang yung kailangan niyo po yung inscribed angle, pero ito po, this is sobra po siyang nearsighted. Hindi niya na makita.
Alright. Okay, so ito, let's connect BC. Just so we get an inscribed angle corresponding to AC. Okay, kasi AC is an arc, And then we want an inscribed angle, so we want another point on the circle, not on AC. Well, we have two choices, B or D. And in fact, I could have chosen, instead of B, I could have chosen point D. If I chose D, I should connect A and D instead. But I happened to have chosen B. So I'm going to connect B and C. So itong angle na minimeasure natin, Z. And then this angle X at B is going to correspond to AC. Can you think of an inscribed angle corresponding to BD? Kita mo? Inscribed angle for BD.
Inscribed angle for BD. Yes. Abo.
What angle is that?
ABC.
Now I'm talking about the smaller arc BD.
DCB po.
Ayun. So let's call this Y. Now, can you think of a relationship between Z, X, and Y?
Yes, the remote angles, the remote angle theorem.
Okay, so tell me. So I can write down the equation.
Angle Z plus angle Y is equal to X. Therefore, 0 plus 1 is equal to 1.
Yeah. So angle Z plus angle Y is equal to X. But it's Z we're measuring, right? So Z is equal to X minus Y. Now, nung X, that's angle ABC. Angle ABC is inscribed for arc AC. So this is half of arc AC. So ito no X. As for Y, which is angle BCD, this is half of its corresponding arc BD. And then angle Z, which is angle APC, is equal to X minus Y. So that's angle ABC minus BCD. They just put everything in, half of arc AC minus half of arc BD. And there you go. Angle ABC is 1/2 arc AC minus arc BD. There it is. Example. Joshua, is this something that you have already encountered before? Are you familiar with this, or is this entirely new? This theorem about...
Nakita ko na po yung mayat, pero hindi ko lang po naalala.
Na ano po, nung kasi pong mas bata po siya, hindi pa kami nakakabili ng mga books. Kaya lang, I went to Don Bosco po, dito po sa Tarlac, kasi kilala po yung mga Suliman, Suliman interact with the, mga sa Don Bosco. So yun principal, kilala po namin na kasi na-improve yung Don Bosco through my uncle. So the principal gave him books na from
Alright,
King
okay.
to, yun po yung ginamit. Andun po doon sa book yun, itong mga ito po.
Okay.
Sa Don Bosco in...
Alright, so hindi naman entirely new. Meron ng degree of familiarity.
Apo.
All right, ito Joshua. Arc XV is 105 degrees. Arc YW is 37 degrees. What is angle YZW?
Yes. Bang, 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 bang. 1/2. Oh wait, is this one of the reasons for the tangent is ganun din po. It's sort of the secant, but then it's just it's just touching only at one point. So
Yeah.
because
So pupunta tayo doon. Yes. All right, but here we're looking at the basics muna. Okay, so YZW. But yes, this is gonna lead to that.
So something something 1/2 xv minus yw.
So okay, just tell me the numbers. 1/2 of, and then the operation.
Xv minus w. My yw.
All right, so xv minus yw. So 1/2 of 105 degrees minus 37 degrees. So this should be 34 degrees. Okay, and then angle B. So letter B, if angle XZV is 27 degrees and arc XV is 104 degrees, then what is the measure of arc YW? Okay. Well, from the same equation, YZW or XZV is half of arc XV minus YW. Then XZV is 27 degrees. XV is given 104 degrees. We are looking for the measure of arc YW. So this is going to be straightforward. 27 times 2 is 54. 104 minus 54 is 50 degrees. Okay, another theorem. So of course, as I've been describing the two situations, I've been talking about secant lines. Okay, for this theorem, I need a line so that I'll be able to extend outside the circle. But here in this theorem, we can limit the discussion to things inside the circle. So through AB, I can think of stating this in terms of the secant line AB, or we could just refer to the chord AB. You were talking about tangents kanina. So yes, doon na tayo pupunta. The circle. Why not? Okay, and then
The,
this is
when your dream comes true, but then it's actually the nightmare.
what? Okay, so this is P, and then let me put a label here to a point Q so that we could easily refer to the following angle QPS.
It does appear po that the S will not secant with Q.
Okay, so PS is a secant line because there are 2 points of intersection of that line with the circle P and S. However, for the other line, it's only a tangent line because it touches the circle in exactly 1 point P. So P is the point of tangency. So the two lines here trap only this angle. So this angle traps only one arc. This arc.
Yung ano po, yung ba po yung sinasabi na subtends?
So ito yung term na subtends. So that angle subtends arc PS. So there is a relationship between the angle and arc PS, which is that angle QPS, right in blue, angle QPS is, what do you think is its relation to the measure of arc PS?
1/2.
1/2.
Yeah.
All right. What I do to remember that, I don't know, did you just happen to remember 1/2 or did you guess it?
It essentially is just the it's just essentially the inscribed angle, but one of them is the secant. The secant just went it got too short.
Right, right. I see. So parang the inscribed angle theorem. So actually, that angle by the tangent and any inscribed angle, they're going to be congruent because they're all half of the arc PS. Okay, but to justify why we have this one half of arc PS property, let's. I'm
So,
not gonna.
kung yung secant po, isipin niyo po yung limit as it goes, it becomes extremely small.
Yes, actually, we can do that. Think in terms of the limiting behavior. Start with, I guess what you're talking about is something like this. No? So you have this inscribed, so P, and then S, and then, so imagine that is fixed, and let's draw this R. Okay, so imagine natin that R is actually not fixed. R is moving closer and closer to P. Is that what you were thinking of?
Abo.
Okay, so kasi in this usual situation, okay, so let's call this arc P, and then let's call this R0. So what we have going on here is that S, well, angle SPR0 is half of arc S and then R0. And then if we move R0 closer and closer to P, what we imagine happening is that instead of chord P R0, we get this tangent. Okay, so from the chord PR0, we immediately get this tangent, and then let's locate point U just so we can easily refer to the angle that's being formed. Nung angle nga pala, so ito yon nung ganito lang siya nung una, but then eventually let's say R0 is here. So no angle, magbabago na siya. Okay, and then the arc will be slightly larger. Okay, but the same 1/2 relationship is still gonna hold. And then until eventually, okay, when the angle gets to this extent, and the arc now becomes arc SP, the 1/2 coefficient is still gonna hold. So angle SPQ is 1/2 arc SP. Okay, so you can think of this as an alternative justification. But instead of using that limiting argument, we can also argue this way in a more elementary fashion. Okay, let's locate the center here. And then connect the center to P and S. Now call that O. P is not just any point relative to the circle and that line. It's a point of tangency, which means we have a 90-degree angle there, which means that this angle we're trying to measure, if we call it Z, then that makes this angle 90 degrees minus Z. All right. QPO is 90 degrees. So if QPS is Z, then that angle there I marked is 90 degrees minus Z. But then radii congruent, so this is also going to be 90 degrees minus Z. But then if you look at PSO, okay, 90 degrees minus Z, 90 degrees minus Z. Question, what is this angle?
I have no
POS. You can figure it out.
It is something minus something. I wonder.
What's that angle going to be equal to?
Mm-hmm.
So we have an isosceles triangle. We know the base angles. We're just
Yes.
looking for the vertex angle.
100, 100 plus 2z.
What's angle POS now?
100 plus 2z.
Huh? So at angle P, 90 minus Z. Angle S, 90 minus Z. So angle O, what's the measure of angle O?
2z po.
Sorry? 2Z. Okay, so if that's 2Z, then what happens to arc PS? What's the measure of arc PS? It adapts, it inherits the same measure of the central angle, and the central angle is POS. So that makes this 2Z as well. And then look here, Z and then 2Z. So the arc is twice that angle there. So that's it.
Proven.
So I haven't even written down the words yet. But since OP is perpendicular to PQ, then angle OPS is 90 degrees minus angle SPQ or QPS. But then OP and OS are congruent. OP equals OS. So angle OSP is equal to angle OPS, which is also 90 minus Z, 90 minus QPS. All right, so now we've justified the angles marked 90 minus Z. So therefore, angle POS actually pwedeng ilagay ko na lang 180 degrees minus twice angle OPS. Wait, let me make this. Since OP equals OS, since we have that isosceles triangle, so POS is 180 minus twice OPS. So we get 180 degrees minus twice, 90 degrees minus angle QPS. So this ends up being twice angle QPS, so twice Z. But then, since POS is a central angle, so let's wrap it up. Angle QPS is 1/2 angle POS. POS is a central angle, and then it shares its measure with the arc PS or SP. So we have 1/2 arc PS. Okay. Okay, so what if our tangent and secant, what if they intersect not at the point of tangency, but what if they intersect outside the circle? So we have point of tangency, Q, and then A, B, and then intersection at P. So this looks eerily similar to this theorem. Okay, two secant lines, and then you get to trap two arcs. So the two lines are both secants, but this time we have two lines. One of them is a secant line, but the other is a tangent line. We still get to trap the following two arcs, BQ and AQ. In fact, ang mangyayari, with BQ and AQ, that they're actually going to be contiguous kasi that they both have Q as an endpoint. So question now is, itong angle na to, is that still related to the measures of the two arcs? Of course, the answer is yes. What do you think is the relationship that holds between angle BPQ and the two arcs?
QA
What's
minus
that?
QB. Then Q1 half QA minus QB.
All right, so
Imagine
one half of.
one of the secants point that secant na ano po, angle would shrink to nothingness.
Okay, so na-imagine mo na how, right? So hindi ko na ipo-prove, hindi ko na ilalagay,
Abo.
Okay.
Similarly for yung tangent din po.
Mm-hmm. Yeah, actually, doon ako papunta. How about if the two lines are both tangents?
Same din po.
All right, so we have.
Pwede rin, meron din po akong naisip na iba pong formula eh.
So here, angle APB equals 1/2. Now we have two arcs, both have endpoint AB, but so I'd be able to distinguish between the two of them. On the major arc, let me choose any point. It doesn't matter which point. So, but after I've chosen a point, let's call that Q. So what do you think? Angle APB is half. Yes, it's still the same result. But AQB minus arc
Or
AB.
even simpler po, it's 180 minus BA.
Yes. 180 minus B. Are you talking about the minor arc?
Yes,
Yeah, the minor arc AB. Okay. Also, okay, angle APB is ano ulit yun? It's
180 minus minor RBA.
Right. Okay. 180 minus RB. And
dapat po yung minor arc pag ganun po. Tapos yung major arc pag ganun.
okay. Baka minsan nakakalito, depende kasi sa pagkaka-drawing eh. Depende sa pagkaka-drawing nila. Okay.
Dapat ganun po para may bago pong para mas madali pong major sa minor.
Example.
Dalawang arcs.
Pwede rin. Major.
A, B, C, D, and then CB and AB intersect at point F. Okay. If angle AFC equals 70
69.
so it can have 70 degrees, and angle AEC equals 20 degrees. Find AC and BD.
maybe we could use some of that algebra.
Yeah, algebra. Sige, tell me what things you want to label.
Algebra. I mean algebra.
Okay,
Algebruh.
algebra. Okay, sige, what do you want to label here?
AC. Actually, we could just use AC and BD.
Okay, sige.
Uh, AFC is one half AC plus BD, while AEC is one half AC minus BD. So adding together, 90 is equal to one half AC. Wait, that doesn't make sense. Hmm.
So if you add them together, 90 degrees equals,
One half 2 AC. Ah, it makes sense. Okay. So 90 is equal to AC. Ah, what a coincidence. Thank you.
yeah.
Okay. So
So
therefore,
what's BD?
BD is something. I don't know. So we can use any of the equations. So 70 equals 1 half 140 minus 90 50. Does it
Okay,
work for that one? Yes, it also works.
yeah,
So
50
50.
degrees.
50 90. Yes. Tang, 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 tang.
Okay, sige, what time do we start?
I don't know.
Past 3 or before 3 p.m., no?
Opo, before 3 yata po.
All right, sige. I think this is a good place to stop. We can stop here. All right.
Opo.
Okay,
Apo.
kasi 5. All right, so I'll see you next time, Joshua and Sergey.
Thank you
Thank you
po.
po.
Okay, sige. Bye.
Bye po.
Bye-bye po.